Today's topic is about linked list implementation of queue. In previous class, we have discussed about how queue is implemented using array implementation. Today, it is about using dynamic allocation. So as you all know, the queue is an first in first out property. That is, we call it as FIFO. The new nodes will be inserted in the rear end and the deletion will happen at the front end. For implementing linked list implementation of queue, we need a structure called node. So it has two parts in it. One is a data part and another one is a next pointer. So data part will contain the value of queue, which element is going to be inserted, that will be stored in data, and the next pointer will refer the next structure node. So next is a pointer. So you can see the coding struct node int data. So int data is going to be a normal data, and next is going to be a pointer, so it is referred as asterisk next. So why do we use struct node before the pointer is that the next pointer should refer a structure of similar type. It should not refer an individual location, it should refer a structure with the two parts in it. One is data part and another one is a pointer part. So the queue will be using two pointers, one is called front and another one is a rear. Initially both the pointers will be null since the queue is empty. So what are the operations that can be performed on the queue? As we know that we have seen in array implementation of list, we can perform enqueue operation, dequeue operation and display. What is enqueue operation? Inserting a new element in the rear end of the queue using rear pointer, and dequeue is the deletion of the element from the queue from front end using front pointer, and display will be printing all the elements from front end till rear end. So we'll start with inserting an element into the queue. We refer it as enqueue operation. So there will be only two parts in the enqueue. So if the queue is empty, that will be a different operation, and if the queue is not empty, you will be performing another operation. So here we have to check only one condition, whether queue is empty or not. Okay, let us see the example for the if the queue is empty. So see the coding. How will you check the queue is empty? When front pointer and the rear pointer, if they are equal to null, then my queue is empty. So what you will do if you want to insert a new element and my queue is empty? So first we will check the condition. See the coding. So void enqueue, it's a function name. It has two parameters. One is x, which is the element that is to be inserted, and the next one is a pointer to the first node. So initially the front node will be null. So once it enters into the coding, you can see if the front is equal to null, that means my queue is empty. That means I'm going to create a new node. You can see the diagram. I am creating a new node. So how I will create a new node? The coding is front is equal to malloc, that is memory allocation, requesting for memory location with the size of struct node. So malloc size of struct node means a memory location with the size of structure node is created. So you can see a node is created with the name front. Now what we have to do, the element to be inserted. So x will be having the element value which is to be inserted. So we'll store it in the data part of the structure. So it is given as front data is equal to x, and we know it is the first and last element. So its next pointer will be null. So how do I do that? Front of next is equal to null. Now this is the one and only element we have. So the rear must be assigned to front. You can see the diagram. I have shown a diagram with an example how 10 is inserted. So first a structure is created as front. In the structure, the data 10 is stored and the next pointer is made null. Then finally rear is assigned to the front. Why rear is assigned to front? Because I have one and only element in the queue. So we have inserted 10. Okay, so I am trying to insert another new element 20. Now in this condition my queue is not empty. That means my front is not null. It is assigned to one particular node, which is 10. So what happens in the coding, the front is equal to null condition will be failing. So you will come to the else part. Now what I'm doing is I'm creating a new node called temp. So where the new node should be inserted, it should be inserted before the rear end. It should be always inserted before the rear end because insertion happens at the rear end of the queue. So what I'm doing is I'm creating a temporary structure. We call it as a temp. So I'm creating a temp structure. Temp is equal to malloc of size of struct node. In the temp structure, I am storing the new value, and this new node is going to be the last node of the queue. So its next pointer will be null. So you can see the coding. Temp is equal to malloc of size of struct node, temp of data is equal to x, and temp of next is equal to null. Now after all the process is done, the new node will become the rear node, because the rear node is the node which points out to the last node that is created in the queue. So we just assign rear to the temp. So what happens? Front will be in the first node and rear will be in the last node. After coming out of this function, the temporary variable will be gone. Only front and rear will be there. Why is it so? Because front and rear are declared globally in your program. So now you have only two elements in the queue, 10 and 20. If I am performing multiple NQ operation with 30, 40 and 50, you can see only the rear end is getting updated. The front end will not be get updated. So the front end will be always referring to the first node, and the rear end will be always referring to the last inserted node. So that how it satisfies the property of queue. So always the new element will be inserted at the last. So here the new elements are inserted at the rear end. Next is DQ. Okay, we'll perform a DQ operation with more than one elements. So now in my queue, I have 5 elements, 10, 20, 30, 40, 50. My first element is 10 and my last element is 50. How do I say that? Because my front pointer is in 10, that means it is the first inserted element, and my rear is in the 50, that means my 50 is the last inserted element. Now according to the property of queue, first in first out, which has come first, that has to come first as output. So the pointer front which is pointing, that should be deleted first. So how do I delete it? You can delete it very simply by just moving front to the next node. So how a front can be moved? You can see the front of next is referring to 20. So now 20, after deleting 10, 20 will become the first node of the queue. So you can perform this operation simply as front is equal to front of next. But why do I use a temporary variable here? Because queue is implemented using linked list. Why do you are going for linked list? Because it's a dynamic location. Whenever there is a need, we request a memory location. When there is no need of a memory location, we must free that memory location for reusing it. So if you are not freeing it, you can't reuse the memory location. So how do I free it? First, I create a temporary variable temp. So I assign temp to the front. So you will be assigning, how will you assign it? Temp is equal to front. Then I am jumping from the first node to the next node. Why? I am going to delete 10, then which will become the first node of the queue, 20 will become the first node of the queue. So how to jump from 10 to 20? You will be jumping from using the coding front is equal to front of next. Now front will be gone to the 20. Now which is the first element of queue? 20 is the first element of the queue. Which is the last element? 50 is the last element. Now temp is simply connected to this list, which will be not referred, which will be not printed, since the queue elements will be processed only from front to rear. Now I can free the temp. Before freeing temp, I print the value that this value is being deleted. So I give a printf statement that temp of data is deleted. After that, I am just giving free of temp. So now the memory location is gone. Only 4 elements are there in the queue. My first element is 20 and my last element is 50. Similarly, if you are performing again a DQ operation, that means 20 will be deleted from your queue. You can see the same example. So first I'm creating a temporary variable struct node star temp. I am assigning the temporary variable to the front. So temp is equal to front. Then I am moving my front pointer to the next node, that is 30. How do I move it? Front is equal to front of next. Then I am printing that the 20 is being deleted. How do I do that? Temp of data. Then finally I am freeing it. So free temp, and 30 will become the first node and 50 will be the last node. Now let us consider all the elements are deleted, only one element is there in my queue. That means my front and rear are standing in the same node. See here example that there is only one element in my queue, that is 10. Both front and rear are standing here. Now let us see how this coding works. So first, as usual, we'll create a temporary variable temp and assign the temp to the front. So front, rear, temp all will be standing in 10 itself. Now front is equal to front of next. So what is front of next is, it's null. So when front is assigned with front of next, front will become null. Then I'll be printing 10 is deleted, then the temp will be freed. So what happens? Rear and temp both will be erased. Now what happens is my queue is empty. So I have to make the rear pointer null. Why do I have to make? Otherwise it will be referring some garbage value. So here I will be taking it as if front is equal to null, just assign rear is equal to null. So this coding will work only if there is one and only element in the queue. Why do I do it? If the one and only element is deleted, my queue will become empty. So if queue is empty, both front and rear should be null. The next operation in queue is displaying the elements of the queue. So there will be only two conditions. One condition, we have to check whether my queue is empty or not. As usual, how do you check it? You will check whether your front is null or not. If it is null, my queue is empty. If it is not null, you will print the elements. Now you will see an example. If my queue is containing 5 elements, 10, 20, 30, 40 and 50. Front is in the first node, rear is in the last node. So you'll check the condition, see the coding. If front is not equal to null, that means my queue is not empty. So what I've done is I've given a very simple constrained coding, only 2 lines. You can see I used a for loop. So inside for loop, first initialization, what I done initialization is I created a temporary variable called L, struct node star L, which is assigned to front. So what happens is L will be standing in front. Now I'll check the condition if L is not equal to null. Is L is not equal to null? Yes, because it is standing in 10. So it prints the data 10. So 10 arrow mark. Again L is equal to L of next. Again L is equal to L of next. From 10 L will jump to 20. Again check the condition whether L is not equal to null. Yes, it is true, it is not equal to 2. So it will print 20. Then again L is incremented, that means L goes to L of next. From L 20 of next is 30, so L will be going from 20 to 30. Now L will print 30, then L will go to 40, then L goes to 50, again 50 will be printed. After printing 50, L goes to L of next. Now 50's next part is null, so L will become null. The condition L is not equal, it is false, so it will come out and it will print null and will be displaying all the elements. Now it will print 10, 20, 30, 40, 50, null. Okay, how do we write a program? So first thing is you will have 4 parts, 3 plus 1 plus 1, you will have 5 parts here. The first part, you have to write the coding for creating a node. Then you need a main function. So what I did in main function is I have assigned front and rear as null. Then I am getting 2 variables. One is choice and an x. Choice is going to be for getting the value of the menu and x is going to be the input value. Now what I'm creating is I'm creating a while loop here. I'm just printing 1 is for insertion, 2 is for deletion, 3 is for display and 4 to exit. Now I scan. Now what is the input you will get, you have to give here is if you give 1, you'll go for insertion. If you give 2, you'll go for deletion, and 3 for display. So based on the choice, that particular function will be called. So in case 1, I get the value of x because that is the value that is going to be inserted. That x is passed through NQ and front. So this is case 1, and in case 2 what I do is I don't want to get any value because we are going to delete the elements from the queue which is coming out first. So you just pass the pointer alone to the queue. So DQ, I am passing the pointer value of the first node. Then similarly for display also I am sending the pointer of the first node. So the rest of the coding we have discussed previously. So NQ is for inserting element and DQ is for deleting the element and display is for displaying. So that's all. The examples have been given for how a queue is implemented using linked list. Thank you.